So, hello students. Today we discuss the worksheet that is Redox reaction 2 worksheet. So, in that the first question is which of the following is a disproportionation reaction? So, in that there is only one disproportionation reaction is there. So, I think that is option 1. So, the reaction of chlorine in NaOH forming sodium chloride, sodium hypochloride, H2O. So other three options are that is only one oxidation or one reduction is there for a particular element. But in this reaction only the chlorine is present in two products. Here Cl to oxidation 0. Here Cl oxidation number, we know that Na plus Cl minus 1. Here Cl oxidation number, this is sodium plus 1, oxygen minus 2. If you take ClXl, so here Cl oxidation number we will get plus 1. Means here the chlorine from 0 to minus 1. Here chlorine 0 to plus 1. Means here chlorine reduced. It is the reduction of chlorine. Here Cl2 to Cl1. Cl2 power 0 oxidation number 2. Cl plus 1 it is oxidation. So here Cl undergoes oxidation and also reduction. So this reaction is an example for disproportionation reaction. Next see the question number 23. So it is there, in which of the following changes which have a, I am not writing the total question, I am simply giving the clue. Okay, so transfer of 5 electrons. In which of the following there is a transfer of 5 electrons are present? So the given options are MnO4 minus 2, Mn plus 2. So actually we have to check the all options. This is chromate. Okay, CrO4 minus 2 chromate, 2 chromium ion. Next MnO4 minus 2. This it is given, sorry, MnO2. Cr2O7 minus 2 giving 2 Cr plus 3. So we have to find in which change there is a transfer of 5 electrons are present. So compare the oxidation number here, manganese oxidation number, so 7. So how you got it means, you know the general method, MnO4 minus for x calculation, x minus 8 equal minus 1, x equals 7. The manganese oxidation number plus 7, plus 2. So plus 7 plus 2, here change of 5 electrons. So gaining or losing it is not given. Just we have to identify in which 5 electrons are transferred. It may be gaining or may be losing. I think the first is the correct option. So plus 7 become plus 2 means a gaining of 5 electrons. So I think the first is option. We check the others also. What is the chromium oxidation number here? In CrO4 minus 2, what is the chromium oxidation number? X minus 8 equal minus 2. X equals 6 plus 6. The chromium plus 6 here plus 3. So chromium plus 6 become plus 3 means gaining of 3 electrons. Here manganese, how do we calculate? Sorry, it is MnO4 minus 2. So how we will get what is the manganese oxidation number? So Xl minus 8 is equal minus 2. 6. Here manganese oxidation number plus 6. Here manganese oxidation number MnO2, that is x minus 4 equals 0, x equals 4. So plus 4 2 plus 2 means there is a gaining of 2 electrons. Here again each chromium is plus 3, we will know. I have done many times to this example. 2 chromiums are in the plus 6 and plus 6 conditions. The 2 chromiums are in plus 3 condition. So here it is a gaining of 6 electrons. So the calculating the number of electrons is very important. That's why we done even we know the answer just at the first option. So but we done all the options to know the how process, to know the procedure, how to know the number of electron transferred. Okay, let's see the next question. See, when iron, the question is when iron is added to copper sulfate solution, copper is precipitated. Copper is precipitated due to dash. So here we have to know the reaction of iron. So we have to know the reaction between iron and copper sulfate. So it is given the copper is precipitated. So first we see the reaction. So iron when added to copper sulfate aqueous solution actually. So here there is a formation of copper precipitation and there is a formation of FeSO4. Okay, so what is the importance of this reaction is that in this reaction reverse reaction is not possible. Means when copper is added to ferrous sulfate, there is no formation of iron and copper sulfate because iron is strong reducing agent. Strong reducing agent than copper. So therefore iron replaces the copper. Iron replaces the copper from its solution. So whereas copper is a weak reducing agent, its reducing power is less than iron. So that's why copper cannot replace the iron from its solution. So here, so actually what is the position of copper in this? Here this is equal to Cu plus 2, SO4 minus 2. So Cu plus 2 becomes Cu0, means what happens? Here copper is reduced. Copper is reduced by iron. So in the options it is given I think the second option, the correct thing is given, the reduction of Cu plus 2. The reduction of Cu plus 2 to reduction of Cu plus 2 to copper. Here iron is a good reducing agent compared to the copper. Okay. Already this can be this reactivity series already we discussed in the this language of chemistry concepts, that is reactivity series of metals, we know that. Okay, means here so iron can reduce the copper from its solution, but copper cannot. Okay, because iron is a strong reducing agent than copper. Okay, see one more question. This is question number 25. So that is a solution of SO2 reacts with so the solution of sulfur dioxide so reacts with H2S. So precipitating sulfur So what the question is here, SO2 acts as, so here in the options is given oxidizing agent, reducing agent and other one. So here, so we know the reaction already in the last worksheet. We know the reaction, the SO2 when reacts with the H2S, that is a formation of H2O and precipitation of sulfur. It is exactly, it is given the sulfur is precipitated. Okay, so here two oxygens. First we balance it. So no need to balance exactly, because here we must know just what is the nature. Okay, here H2SO2 acts as an oxidizing agent or reducing agent. Here see sulfur reacts with H2S. What is the oxidation number of sulfur? The hydrogen sulfide means here sulfur is -2 position. What is here sulfur position? 0. So S -2 becomes 0. So the sulfide becomes sulfur, means oxidation number increased. So it is example of oxidation. So it is done by reacting with SO2. So therefore we can say, sorry, here SO2 acts, here SO2 acts as an oxidizing agent. Okay, see one more question. So question number 28 is MnO2 plus 4H plus X 2 plus 2H2. So I have to find the X value. Here X equal, actually the answer given in terms of electrons, means we have to find what is the number of electrons in the place of X. This is nothing but based on the balancing the charge. What is the charge at the left side? Left side the charge is +4. We don't know about the X. So just we are writing the +4 charge. What is the charge on the right side? That is +2. So it is given already, it is balanced. So except X it is +4, it is +2. But we know that the charge must be balanced. The answer is given in terms of electrons kabatti. So how many electrons will be there? Here +4 is there, +2. We know that always electrons are added the side where the charge is highest. And how much charge is there? +4, +2. How much quantity? How many units highest? 2 units are highest. So if you add 2 electrons means nothing but what? -2. So total become +2 +2. So therefore here X equal to 2 electrons. Okay. So there is one more question is, so same question. So actually the balancing the charge by adding the number of required number of electrons is very important. That's why we are adding one more. That's why we are doing one more question based on it. Okay, so plus X. So again the same question here. X equal to dash electrons. Again it is based on balancing equation. Balancing the charge at the left side -2, the right side except X. We don't know the X value. We have to find the X electrons. This is -2 plus 2 moles are present, total 0. This is -2 0. Numerically which is having the highest quantity? This is -2 0. This is numerically highest value. How many units highest? This is -2 0 means it is having a 2 units are highest. 2 units highest kabatti we have to add 2 electrons plus 2 electrons, and automatically the total charge becomes how much? So -2 minus 2. Therefore, here x equal to how many electrons? Here also 2 electrons. Here left side, here the right side. So just don't write directly to the answers. So you have to try. So writing the total board on the notes is not important here. It's because we are again explaining the total mole concept to stoichiometry lessons just to make clear the concept of this topic. Okay, so try to understand uh, how we are dealing the every question. That's important. Just writing the notes is not an important one. First listen the topic, then afterwards you can write the notes. Okay, so see the next question, that is the question number 32. So a reaction is given, the Cr2O3 to aluminium. So given, so already I think balance equation is given, Al2O3. You have to find the reducing agent in this reaction is, the reducing agent in this reaction is what? So we know that what is reducing agent? Reducing agent means which is itself oxidized. Okay, means we have to know which is oxidized and which is reduced. So here just it is given chromium. So chromium oxidation number 0 and aluminum oxidation number 0. Here what is the chromium oxidation number? Cr2 32x. So here chromium oxidation number 3. Like the two chromiums are there. Okay, two chromiums are there. That is 3 comma 3. They are 0 comma 0. Means so here the chromium oxide is reduced because its oxidation number decreases. So its charge minus plus 3 plus 3. The total charge of chromium is plus 6. And so just we are discussing about the electrons. Reducing means simply we can say plus 3 to 0, it will be reduced. The oxidation number decreased, so we can say it is a reduction reaction. So but how many electrons are plus 6 becomes 0, means the gaining of 6 electrons. Next, what about aluminium here? So aluminium 0 2 becomes Al2. What is the condition? 2x minus 6 equals 0. So x equal 3. So 2 aluminiums means 3 comma 3 means it becomes 0 to 3 comma 3. So 0 to 3 comma 3 means it loses its oxidation number. Increase means gaining of, so losing of electron. This is minus 6 electron totally. So here, therefore here aluminium is oxidized. This is oxidation reaction. So which is oxidized, so automatically we know it reduces the other compound. So here aluminium is this is the answer. So actually I think it is the option. So I don't know the exact what is the number of option. So the answer is aluminium is the reducing agent. Okay. Reducing agent as itself it is oxidized. Okay, so see the next question. Means you should be very perfect knowing the oxidation number concept. Okay, so by knowing the oxidation number concept only, you may know which is oxidized, which is reduced perfectly. Then only we are able to do the this type of questions. Okay. Next, see the question number 38. Which of the following is not an example? which of the following is a not an example of disproportionation. So the options are given. We have to check the every option. So the first problem is this only. We know that the chlorine is oxidized or reduced. So this is an example of disproportionation reaction. So we have to know which is not an disproportionation reaction. See the second question. Given that P4 white phosphorus. P4 means here it is a white phosphorus. Reacts again, it is also with caustic soda. Caustic soda means sodium hydroxide. So I think it is also disproportionation reaction. So here from 0 to -1 and from 0 to +1. So it is the first one is a disproportionation reaction. Already we explained it in the question number 1. Okay, that is question number 22. So next here P40. What is the oxidation number of phosphorus? Why are comparing only phosphorus? Why not for sodium? Means so why we are comparing only the phosphorus and chlorine means other elements oxidation number cannot be changed. Just in some exceptional examples, but here these are the common examples. Sodium always shows +1. Here reactant side +1, product side +1. So no change. Oxygen -2, -2. Hydrogen +1, +1. So to know the oxidation reduction, just we have to check those elements where the possibility of increase and decrease in the oxidation state takes place. So here phosphorus 0. What is the phosphorus oxidation number? Hydrogen 3 x equal -3. Mean phosphorus from 0 to -3 it is reduced. So phosphorus undergoes reduction. In this example 1 plus 2 plus x minus 4 equals 0. So this is 3x minus 1 equals 0. X equals 1. Here it is from 0 to 1 oxidation number increased. Oxidation number increase means so it is oxidation. So means only one element, the phosphorus undergoes oxidation and reduction. Means so I think you all know the definition of disproportionation. Disproportionation reaction means this is the one of the types of redox reactions in which only one element undergoes oxidation and also reduction. In the first reaction, Cl undergoes reduction and oxidation. Here also phosphorus undergoes reduction and oxidation. So this is also example of disproportionation. But here we have to, in this question, we have to find which is not a disproportionation reaction. Next, there is one more option. We check the third option. Sodium hydroxide 2F2. 2NaF plus OF2 has 2. See here, there is no change in the sodiums. Okay. Next, is there any change in the oxidation numbers? So here fluorine, it is also -1. Here also -1, -1. There is no change in the sodium oxidation number. So I think it is not an example for disproportionation. So we check the oxygen oxidation number. So what is the oxygen oxidation number here? Here oxygen oxidation number is -2. You know that in all cases oxygen having -2 except in some cases. That is also in peroxides, superoxides. In the presence of fluorine, oxygen shows different oxidation number than -2. So NaOH is a normal base, oxygen having -2. But here Fluorine always plus 1. What is oxygen oxidation number? So sorry, fluorine always minus 1. So here, sorry, x equal to 2. So here oxygen oxidation number minus 2 to become plus 2. Means it is oxidized. It is minus 2 to plus 2 means it is oxidized. Well, what about here H2? In H2 there is no change in the oxidation number minus 2. Means here the oxidation of oxygen takes place. How means in sodium hydroxide reactant oxygen oxidation number minus 2, but in the product in this compound OF2 oxygen having plus 2, so oxidation number increased. Oxidation number increased means oxygen undergoes oxidation, but it is not a redox reaction. It is only oxidation takes place. There is no reduction. There is no reduction. So that's why we can say it is not a disproportionation reaction. Only oxidation takes place here. There is no reduction. Means the answer is this one. So we have to check the next question also. Sorry, next option, not the question. In the same question, the fourth option is also there. What is the fourth option? The 2 hydrogen peroxide, the reaction is given. So see the hydrogen peroxide's decomposition reaction. Okay, so here see this is the hydrogen peroxide. This is hydrogen peroxide. Oxygen oxidation number is minus 1. Each oxygen having minus 1 oxidation number. In normal H2O, oxygen is having minus 2. And here this is oxygen free element, oxygen oxidation number 0. The oxygen oxidation number 0. So see the oxidation from minus 1 to 0. So increased. So it is the oxidation. Save the oxygen minus 1 to minus 2. It is an example for reduction. So here oxidation undergoes oxidation and also reduction. So it is also disproportionation reaction. Actually we have to remember the first option, second option, these 4 options, because these 3 are the generally treated as the best example for to explain the disproportionation reactions in which only one element undergoes both oxidation and reduction. But in the question it is given which is not undergoes disproportionation reaction. So the option 3 is the answer. Okay. Okay, see the next question, that is okay. So nitric acid acting, so the question is given nitric acid, that is HNO3. It is acting as an oxidant. It's an oxidant in a certain reaction, and transfer 4 moles of electrons. This is an important model. Electrons per mole. So it is the product. So the product may be. So I have to check the answer. Means here it is given HNO3, nitric acid works as oxidant. Oxidant means oxidizing agent. It means itself it is reduced. So how it is reduced means 1 mole of that compound loses 4 moles of electrons. Okay, means there must be oxidation number difference, that should be 4. 4 number difference on the oxidation number. So first we see the options, given options. 1 mole of nitrogen dioxide. The second option is 1 mole of ammonia, half mole of N2O. See the fourth option, 1/2 mole of N2. So how to solve this problem means first we see the question. HNO3 acting as oxidant. So HNO3 given means what is the nitrogen oxidation state? Actually it works as oxidant. Oxidant means itself it is reduced. So by the transfer of 4 moles of electrons. So oxidizing agent means itself it is oxidized. So oxidation means it loses electrons. Sorry, it works as oxidant. So itself it is reduced. Reduced means gaining of electrons. But how many moles are, it is not given gain, but we know that it works as the oxidant means there is nothing but gaining of electrons. Okay. Oxidant means the works as a oxidizing agent, itself it is reduced, so gaining 4 moles of electrons per mole. Okay, 1 mole formation law, 1 mole reduction law, it gained 4 electrons. So what is the oxidation number of nitrogen? And X equal to 5 oxidation number. X equal 5 oxidation number in the nitric acid means we have to compare this with all options. Okay. So here what is the oxidation number of nitrogen? This is plus 4. What is the nitrogen oxidation number here? That is minus 1/3. This is 1 plus 3x, x minus 1/3. Here what is the nitrogen's oxidation number? 2x minus 2 equals 0, x equal to 1. So 2 nitrogens are having 1, means 1 nitrogen is having how much? 1 nitrogens. So 1 mole of compound it is given how much? The per mole, the product, electrons per mole. Okay, the product per mole means here 2 nitrogens 1. So for 2 nitrogens it is 2 electron. Half mole means there is only 1 electron, means here oxidation numbers plus 1 and plus 2. But here 5, oxidation number plus 5 becomes 2, oxidation number plus 2. It is only given 1 mole. So 1 mole, sorry, that is given only half mole. So half mole, so I think it will be the answer. Because manaki difference enta ravali, difference 4 electron difference ravali. So here oxidation number enta undi 5 only. Here oxidation number how much? This is plus 2 is the plus 1 comma plus 1. But it is for 1 mole. If you take the half mole, so total it becomes 0.5 and 0.5. So here for 2 nitrogens it become plus 1 plus 1. I think it will be the option. So again see here the nitrogen oxidation number 0. Half mole means 1 nitrogen having again 0. Okay, 5 becomes 1 mole, that becomes 0. So half mole of nitrogen only. Half mole of nitrogen means minus 0.5. So there is no change. So it is the correct answer. Okay, so it is called nitrous acid. It's also known as laughing gas. So I will explain detailedly to it. So HNO3 becomes N2. Just we are calculating for 1 mole. Okay, 1 mole. Okay. So here x equals how much you got? 1 plus x minus 6 equals 0. X equal 5. Nitrogen oxidation number plus 5. Here nitrogen oxidation number, so here X equals we get 1. So each nitrogen having 1 means the total nitrogen is changed to plus 2. Okay, total nitrogen's oxidation number, so plus 1 comma plus 1. So plus 5 to plus 2 it will become generally. So plus 5 to, if you do it for 2 moles. For example, 2 moles compared with that. 2 moles compared with that. So what is the oxidation number? This is plus 5 comma plus 5 become plus 1 means the plus 10 becomes plus 2. What is the change? What is the change? That is a gaining of 8 electrons. So have to calculate it for 1 mole. So 1 mole means obviously we will get 4 electrons. Okay, for 1 mole we will get 4 electrons. Because we calculated for 2 moles. For 2 moles we got 8 electrons. For 1 mole we will get just 4 electrons. We have to know that only. Okay.